Let's go ahead and do a couple more. These ones are a little more complicated because they have 3 parts. So they're going to be more boundaries we're dealing with. So notice there's a 2 shared in both and then a 4 on this one. So I'm going to go ahead and put boundaries at both 2, so right here, and at 4, right here. It's going to be a little harder, but not much. And then I'm going to go ahead and place each one. So the 2x minus 3 is going to go wherever x is less than 2, so that's the farthest right, or left, sorry. So over here. The 1/2 x, this is saying it's between 2 and 4. So I'll put 1/2 x right here. And then last but not least, the 1 will go on the farthest section. And I'll even highlight those accordingly. Okay, once again, we're going to go ahead and make our table. The table's going to be a little interesting this time, and I'll show you why. There is one table for this one, the 1/2 x, and there's also a table for this third one. And here's the deal. The 2x minus 3, the only number we need is the 2 because that's the only one in the inequality. The 1/2 x needs both the 2 and the 4. And then the 1, we're going to have the 4 in that one. Let's go ahead and determine which of these are open, closed, and so on. So these are all from the boundaries. So we do need to decide, is it open, closed, and whatnot. So for the 2, this first one, oops, I meant the eraser. There we go. So it says x is less than 2, so it's not equal to, so it's open. And then the next one, it says 2 is less than x, so this one's also going to be open. I'm just going to put an O for open. And then for the 4 has a less than, or its x is less than 4. So it's not equal to, so that one's also open. And then we go to the last one. It says x is greater than or equal to 4. So this one's going to be closed. So it's the C for closed. So that's the only one that's going to be closed. So let's go ahead and plug them all in. So for the first one, we got 2 times 2 minus 3. That is equal to 1. So I'm going to go to 2, 1 right here, and I'm going to put an open circle. Once again, I actually need at least 2 points in this left section, so I'm going to plug one more point in. Let's go to the right one, so we got, or sorry, to the left one, so to 1. And do the same thing. So we have 2 times 1 minus 3. That will equal negative 1. So I'm going to go right one, down 1. And I just draw just in this left section. Okay, the next section is the 1/2 x. So I'm going to do a 1/2 times 2 for this one, which is just 1. So I'm going to do 2, 1, but it's also open, so just keep that open. So this is an example where it'll stay open. Then we're going to do the 1/2 times 4, which is 2. So I'm going to go 4, 2. And that's also open. And I have 2 points in that middle section now, so I'm just going to go ahead and connect those two. Okay, the last section, we also need 2 points. We've got 4, but notice how this equation doesn't have an x, it's just 1. That means it will always be 1. So even if I put 5 in, our answer will be 1. If I do 6, it'll be 1. So, and this one's closed, so we'll go to 4, 1 right here. It's a closed dot just below that other one. And 5, 1 and 6, 1. So all these are going to be 1s, which means it's just going to be a horizontal line across 1. And there is your answer. So let's go ahead and do another one so that we feel good about that. This one has a lot of little boundary sections, but that's going to be okay. So we've got -3, we've got -1, -1, 0, and 4. So let's do each of those one at a time. So we've got -3. We've got -1. Ooh, this is going to be tight. We've got 0. Getting complicated here. And then we've got 4. Okay, so we got to be extra careful because if you notice, we actually have 1, 2, 3, 4 sections, but only Oh, I lied. 5 sections. I missed one. It's 1, 2, 3, 4, 5 right here. We only have 3 equations. So that means 2 of those sections won't have an equation. So we got to be careful about where it goes. I'm going to zoom in. Well, let's do it just one at a time. So we've got x plus 3. That one says it's between -3 and -1. So that's this section right here. So this is the x plus 3. Then it says that 3 is between -1 and 0. That's this little section right here. And then x minus 3 is between 0 and 4. That's this other one right here. It's kind of gross because they're so tight. I'm going to move my 3 tables so that I have some space to write in them. So let's look at the x plus 3. X plus 3, if you look back up here, it's between -3 and -1. So we need to make sure we put both of those. So we've got -3, -1, and we only need at most 2 on each table. So we're going to be done with this table. Let's go ahead and determine if they're open or closed while we're at it. So -3 is right next to an equal to symbol, so this one's going to be closed, so C for closed. And the -1's right next to a less than symbol, but not equal to, so this one's going to be open. All right, and let's go to the next one. So the 3 is between -1 and 0, so we need both of those. In fact, that will be the 2 that we'll use. -1 is next to an equal to symbol, so that's closed, while the 0 is next to something that's not equal to, so we're going to do open. And then our last one, it's between 0 and 4, so we're going to use both of those numbers, so we won't need to pick any other numbers outside of that. And both of those are closed because they're both equal to, so closed, closed. Well, let's start plugging things in. So -3, so we're plugging it into the x plus 3. I'm just going to write that up here. So -3 plus 3 is 0, and -1 plus 3 is 2. So let's plot those. So we've got -3 from the origin, 0, and that's closed. And then -1 up 2 is open, and I'll connect those in between this section. The next one is easy because it's just plain old 3, so that means the y value is always going to be 3. So that -1, 3, it's closed, fill that in. And then at 0, 3, it's open, and we'll just put a line between those. And then the last one, we're doing x minus 3. So 0 minus 3 is -3, 4 minus 3 is 1, and they're both closed. So we're going to go 0, -3, and 4, 1, and connect the points just in that section. And there's your graph.